Hi, this is Mr. Manley, and today I'm going to talk about polynomial and rational inequalities. You're probably pretty familiar with inequalities. Maybe you've seen in linear inequalities quite a bit, seen inequalities in combination. That is, maybe you have x plus 5 is less than 7 and greater than or equal to 0, something like that. So you have some experience with inequalities, but here today we're going to look at these polynomial inequalities and rational inequalities. So if we look at this inequality that's given here, what we want to do is set it to 0. Just like when we have a polynomial and it's an equality, we set it equal to 0. We're going to set this inequality to 0. So I'm going to add the 48 to both sides. And then from here, the key point or the key element is going to be to factor it. Since this is a cubic, we're looking at factoring by grouping. If we couldn't factor it by grouping, I would expect that you'd seen a previous lesson where you use the rational root theorem by looking at the leading coefficient and the constant. But fortunately, we didn't get to that point in this case, and we were able to factor it. I can factor this further, the x squared minus 16, after I've taken this line here and factored it by grouping. So let's go ahead and take the next step and finish the factoring. And then from here, it kind of looks familiar, but you have to be careful. Now, we have the zero product property, which might lead you to think that you could set up something like this. And then I could continue on with the final root. So this is how the zero product property worked, but that was when we had an equality. So here we have an inequality. And it would take me a few minutes to explain why the zero product property doesn't work for an inequality. But you'll just have to trust me that it doesn't. And if you have a question about that, you can find a video, ask your teacher, or if you're in my class, you can ask me. So we're not going to be able to use this. This here is not going to work. So we're going to have to find another technique. And the technique that we're going to have is kind of like it's almost like a guess and check. It's almost like using the zeros from the zero product property. I'm going to take each of these, the zeros that I would get from each of these. So what would I get? I would get 3/2, -4, and 4. And I'm going to graph those on a number line. So I would have -4, I would have 3/2, and I would have 4. And then the idea here is to look at a value in each of these regions. So if I took a value in this region over here, look to the left. So if I took a value in that region over there, what would be over there? Like a -5, right? And then what would be in this region here? We could say a 0 would be a really convenient value to take. And then in the next region, say a 2, and in the next region, say a 5. And all I really want to do is know what does each of these values do as far as affecting, or when I plug it back in here. So if I plug it back into this polynomial there, what happens to each of the factors? And I really just need to know the sign. So look again down to the left. So if I look down to the bottom left, there's that -5. If I plug that into 2x minus 3, that's going to be a negative, because I'm going to have -10 minus 3, which is -13. I don't need to get into the specifics of -13. I just need to know that it's negative. And then if I plug in the -5 for the x plus 4, that's going to be -5 plus 4 is a negative. And if I plug in the -5 for the -4, for the x minus 4, that's going to be a negative as well. And it doesn't matter what the specific value is. All I need to see is, look here, down at the left, I'm going to have a negative times a negative times a negative. So whatever those values are, I'm going to have a negative times a negative times a negative, which is going to be negative. And I'm circling that down in the bottom left. So any value that is in this region over here, any value that is in this region over to the left is going to come out negative after I plug it in for each of these x's up here. And what am I really interested in? I'm really interested in, look to the right there, greater than 0. I want to know when I plug a value in for x, is it coming out greater than 0? In this case, no. It comes out negative. So none of these solutions over here will work. I can just cross all those solutions out. That's not going to be part of the solution. Moving along to the 0. This will be easy to plug in, right? If I plug in a 0 for x, I plug in a 0, I get a negative. I plug in a 0 for x plus 4, I get a positive. I plug in a 0 for x minus 4, and I get a negative. Okay, that's a negative times a positive times a negative. What's that going to be? That's going to be positive. So I'll write that down at the bottom. That's going to be positive, and that is in the solution, right? Because I want to be, again, greater than 0. So we will take that. Can I be equal to 0? No. So the negative 4 would make it equal to 0. If you look on the number line at negative 4, and the 3/2 would make it equal to 0. So I do not want to include those in my solution. I just want to include the values between. So it's really just going to be these values in here, but not the negative 4 and not the 3/2. Plugging in the 2, so I'm going to move up to the 2 now. If I plug that in, I'm going to get a positive. When I plug in a 2 for x plus 4, I'm going to get positive, and when I plug in a 2 for x minus 4, I'm going to get negative. Positive times positive times positive is negative. So these here are not in the solution. And on the right here, at x equals 5, I'm going to get a, when I plug in for 2x minus 3, I'm going to get a positive value. For x plus 4, I'm going to get a positive value. And for x minus 4, I'm going to get a positive value. So positive times positive times positive is positive. 4 is not included. If you look at the 4 on the number line, I'm not including that. And then I'm including all of these on the right. So I can actually see the solution on the number line there, but I want to express this using interval notation, which you may or may not be very familiar with. So if you can't read my interval notation here, you're going to need to review that or get some special instruction on this. So my solution is going to be from negative 4 to 3/2, but not including 3/2, union, and I'm going to go from 4 to infinity. And that's my solution. Okay? Let's go ahead and look at another one, a rational function. Here. It's going to work very similar. I'm going to set it to 0. Then I'm going to want to subtract here, find a common denominator and subtract. And I want to simplify this result. So that'll be negative x plus 8 over x minus 5 less than or equal to 0. Now in the previous problem, I got these, you'll recall, I got these values, this number line down here based upon the zeros of the polynomial, this polynomial here. For this one, I'm going to get my zeros from the numerator and the denominator. And then from there, the process is going to be the same. I'm going to choose a value over here. Let me do that in a different color. Here, a value here, and a value here. And then I'm going to plug those in and see if I get positive or negative. So when I plug in a 4, I'm going to get negative 4 plus 8, which is positive, divided by 4 minus 5, which is negative. So that'll be a positive over a negative, which is negative. That's in the left region. In the middle region, if I plug in a 6, I'm going to get negative 6 plus 8, which is positive, over 6 minus 5, which is positive. That's a positive over a positive, so the middle region is positive. And on the region on the right, I'm going to have negative 9 plus 8, which is negative, over 9 minus 5, which is positive. So that'll give me a negative. Now what do I want? I want here less than or equal to 0. So let's look at where is it less than or equal to 0? In other words, where is it negative? Okay, it's negative over here, negative, all in this region, and then it's equal to 5. And we can be equal to, remember, so 5 is included. And then it's negative over here. Look at the right, it's negative there in that whole region. And it could be equal to 0, so 8 is included, and then everything to the right. And again, writing this in interval notation, I'm going to have negative infinity up to and including 5, so that gets a bracket, union, and we'll go from 8 up to infinity, and that is your solution, and that is polynomial and rational inequalities. So I think if you get the idea of finding the factors and evaluating just whether it's positive or negative, and seeing whether or not it's less than 0 or greater than 0 that you're looking for, and you should be able to do these types of problems. Thanks for checking this out, and if you have any questions, ask your teacher.